We're going to prove the following lemma, that if G is a 2-3 tight graph, and V is a vertex of G that has degree 3, then no 2-3 tight subgraph of G minus V contains all of the neighbors of V. We're going to proceed by contradiction. So, let's name the neighbors of V. Let 1, 2, and 3 be the neighbors of little v, and suppose there exists a subgraph H of G minus V containing 1, 2, and 3. So if we were going to make a little picture, it might look like this. There would be the big graph G that would contain all sorts of things, including 3 vertices, 1, 2, and 3, and another vertex V, maybe I'll make that a little better, to which all 3 of those are connected. Okay, and then what's in the blob is G minus V. So everything in the graph G except the vertex V and the 3 edges that connect it to vertices 1, 2, and 3. All right, so suppose there exists a subgraph H of G minus V containing 1, 2, and 3 such that H is 2, 3 tight. So H looks something like this. It's contained in G minus V, and it contains the 3 vertices 1, 2, and 3. So H is somehow sitting there. And let's introduce some notation. So let NH equal the number of vertices in H. So by 2-3 tightness, H has 2NH minus 3 edges. Now let's define a new graph, H prime. Define H prime to be the graph H together with the vertex V and the edges 1V, 2V, and 3V. So if I put this new graph in the picture, H prime looks something like this. It contains H and that extra vertex and its and those 3 adjacent incident edges. Okay, so let NH prime equal the number of vertices in H prime, and we know actually it just has 1 extra vertex, so it's NH plus 1, because H has the vertices in, or H prime has the vertices in H plus that extra vertex V. Now let's see how many edges H prime has. So we see that H prime has how many edges? Well, it has edges of H, so the number of edges of H plus 3 additional edges. And number of edges plus H of H is 2NH minus 3 plus the 3 additional edges equals 2NH edges. Okay, but it also has, I guess, but if G is 2,3 tight, since G is 2,3 tight, H prime must have less than or equal to 2 NH prime minus 3 edges. However, if we look at 2NH prime minus 3, well, NH prime is NH plus 1, and then I have the minus 3, and this is 2NH minus 1. Since H prime has 2 NH edges from star over there. Oops, now I have to put my star in. From star, what we see is that this violates the 2,3 tightness of G. Therefore, we have a contradiction.